We want to make our model as general as possible, and that's because we have not observed any data set. We have not collected any observations. Therefore, we want to make the model as general as possible. But then the structure of the model would follow this mathematical equation. So when you look at this left-hand side, y of S and T, these are the measurements. So this could be like PM 2.5, black carbon, and the measurement that we take. And then the right-hand side, I have four components. The first component mu would be the parameters that vary with time. So we're looking at something like a temperature measured with respect to time. And the gamma, the next term, is the parameters that represent a temporal trend that have a spatially varying parameters. So this could be like longitude or latitude. Just like a couple of examples. And then the next term, kappa, would be with more complicated spatial temporal dependence. And this is called the dynamic process. And we want to put a random process into the model so that this model can better capture the relationship, this spatial temporal dependence. And this could be considered as a random process as well. And the last term is the mean zero uncorrelated process. And this could be simply taken as normal. This could be a random variable that takes a normal distribution. And this is the error term in the model. And one interesting thing about this modeling technique is the flexibility. And we're using data. We will be using data mining techniques to model the components mu and gamma. And two major techniques, major tools that we'll be using are the classification and regression. And the classification, we can use a k-mean classification to classify these different observations using different categories. So let's say we're looking at different zip code, and definitely there will be a different type of classification among different zip codes. And regression, if you want to make prediction, and the regression is just a standard way to make forecasts and predictions. And if you want to make a prediction on the PM 2.5 or PM 10, then we can make regression useful in our modeling process here.